Hello, my name is Shravya and it's from the Sparks Foundation Data Science and Business Analysis intern. So my task one is prediction using supervised machine learning. So it is a simple linear regression task which is using two variables. Now in this task we have to predict the percentage of a student based on the number of study hours. The first step is importing the important libraries. So the first library which I am importing is Pandas. Now Pandas is used for data analysis and it works with tabular data. It provides tools like data frames and series also for analyzing the data. So the next library which I'm importing is Numpy. Numpy is mainly used with numerical data and it also provides powerful object called array. Next is the Seaborn library. So Seaborn library is built upon the matplotlib library and it is used for data visualization and also exploratory data analysis. It easily works with pandas and data frames. So the next library is matplotlib library. So it is a popular Python plotting library. The next step is to import your data set. So the path of my data set is this. And then we will import the CSV file with all our data given into a variable data. And so then we are printing the data. So this is the data, 24 records. The next step is exploring the data. So here we have to visualize our data. So to visualize our data, so data dot head I am using. So using this, I will print the first five records of my data. Now to visualize 10 records of your data, first 10, you just have to give inside the brackets 10. Then by using data dot tail, I will be printing the last five records of my data. And data dot describe, it is a method which is used to show percentiles, mean, maximum, minimum count of the given data set. Then data dot info, using this I'm printing the complete summary of the data frame. So this is my complete summary. The next step is to check whether duplicates are present or not. So by using data dot duplicated, I'm finding the number of duplicates. The next step is exploratory data analysis. So, like previously said, the module C1 that is used for exploratory data analysis. So, here we are using SNS.distplot and data hours. Again, SNS.boxplot. So, using this, here we are plotting our graph and plt.show. So, PLT is matplotlib library dot show. So, using that, we are plotting. So the next step is data visualization. Here we are using scatter function. So this is used to create a scatter plot graph between the scores and hours. So my X label is hours, Y label is scores, and the title is hours studied versus score. Again, by using show, I am plotting the graph. So the above scatter plot indicates a positive linear relationship between the hours studied and score, which means that as the number of hours increases, the chance of scoring high also increases. So the next step is checking the correlation again by using the C1 module, so sns.heatmap, and by using matplotlib.show, I am checking the correlation between the score and hour. So the finally the linear regression. So here for linear regression, x and y are my two variables and data dot ilog dot values. Using this, my first column values I'm storing in x and my second column values I'm storing in y. And then I'm printing x and y just to show the values. The next step is preparing data and splitting it into training and testing sets. So here we will be using sklearn module to create a linear regression model, and we will be splitting our data using 80 is to 20 rule, which means that 80% of our data will be for training and 20% for testing. So the next step is training the model. So here we will be using linear reg. So in linear reg we will be making a using this we'll be making a linear regression model, and then next we are checking if our training data is fitting or not. Then training is finished, I'm printing training is finished, and the next step is plotting the regression line again by using scatter, and my x label is hour, y label is scores, and plt dot show. and then the testing data. So we have to predict the scores for our test data. So I'm using linear reg.predict to predict the scores of the test data, and I'm printing y test. And then again I'm plotting the testing data line. Next step is comparing the actual versus predicted scores using pandas. I'm comparing and I am printing. Accuracy of a model. Now to check the accuracy of a model, so we will be using sklearn module, and using that we found out that our accuracy is 94.5, which means that above 94, above it shows that 94 percentage, which indicates that above fitted model is a good model. And then model evaluation, which means predicting the error. So here we are predicting the mean squared error, root mean squared error, and also the mean absolute error. And so these are the values of our errors, and since mean absolute error it is less, and we also have that our root mean squared value is good, so we can say that the model is doing a great linear model. Next step is predicting the score. Again, linear reg.predict. So using that I'm predicting the score, comparing your actual and predicted scores. And in this task it is given to predict if he or she is studying 9.25 hours per day, what is the predicted score. For that, again I'm using linear reg.predict 9.25, and I'm printing predicted score for a student studying 9.25 hours. It is 93.69 marks. So conclusion from the above result, we can say that if a student studies for 9.25 hours, then the student will secure 93.69 marks.